Hello, Geometry. This is Lesson 5, Angle Relationships, Part 2. So we're just going to expand what we know on angles and give you some new terminology to use in different kinds of problems to solve. So our first term here is adjacent angles, and these are two angles that share a common side. So looking at this first example here, we notice that angle 1 and angle 2 share a side, obviously where the colors both intersected. So that's why they are adjacent. They share that common side. Vertical angles are two angles whose sides are opposite rays. And another way you can think of that is straight lines. So, for example, here we have two pairs that we can look at. We notice we have two straight lines intersecting, and they form two different pairs of vertical angles. Angle 1 and angle 2 is a pair, and then another pair, the angle 3 and angle 4. And something cool about vertical angles is that their measures are congruent. So angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 4. So they put that on here too, that they are congruent. Complementary angles are two angles that add up to 90. So two angles that add up to 90. So we have two different pictures here. Obviously, angle 1 plus angle 2 would give me 90 because of the little red box that's indicating that this is a right angle. But if you didn't have that picture, you can also check by just taking their measures and adding them up, like in this example here. A is 47, B is 43. Take 2 seconds to add them up, we're going to see that we do get 90. So those are complementary. And lastly, is supplementary. These are two angles that add up to 180. So two angles that add up to 180. And again, we know that 180 is just a straight line. So if I have two angles that form that line, I'm going to know that they are supplementary. So angle 3 plus angle 4 gives me 180. And just a little quick picture here of, I want to go to this quick, vertical angles. A and B are obviously vertical angles because those are two straight lines that give me angle A and B. But if we notice on this example here, G should keep going like this to be a straight line, but instead it takes up. So then we know that C and D are not vertical angles because they're not straight lines. So use the diagram below as each statement true or explain. So angle PAL and angle LAM are adjacent angles. Well, I think so because if you notice, my colors both intersect right here because they share that side. So A is true. Share a side. Angle PAO and angle NAM are vertical angles. So I got to erase this to see if my lines are straight or not to tell. So I had this line here. Well, that one looks pretty straight. Now this one here, nope, it should have went towards M and it didn't. So B is false. Not straight lines. Now last one here, angle PAO and angle NAM, or excuse me, NAO are supplementary. So again, we have to see if they add up to 180. And again, we get that it is 180, so that is true. They are supplementary. True. Add to 180. Mark the diagram for each case. So I'm gonna mark it and I'm gonna erase for the next case, okay? So you keep yours marked and don't erase for each one, all right? So mark DOE and its vertical angle as congruent. So DOE, so this angle right here, now it's vertical angle. Remember, it's the opposite side of it, so like that. Now we're marking those guys as congruent. So you do that by putting, remember, a little arc mark. Those guys are congruent. Okay, I'm gonna erase it now. Mark angle AOE and its vertical angle as congruent. So remember, we need straight lines. If I'm doing this one, I need that line, and then I do this straight line, and I get this guy. So I need this whole angle over there, and this whole angle over here. If I clean this up so you can see it, this angle is congruent to this big angle. And you should use 2 arc marks since you used 1 for the previous example on A. Okay, I'm going to erase. Now our last one here, name a pair of complementary angles. Remember those add up to 90. So this one, don't get tripped up on it. It's not a trick question. Well, obviously I know that DOC is 90, but that's only one angle and I need 2. But if I know if that angle is 90, then I know that this also has to be 90 because 90 plus 90 would give me this straight side right here. Right, so then I know that that's 90. So now what 2 angles make up my red 90-degree angle mark? That would be angle AOB and then angle BOC. Now a linear pair is just 2 adjacent angles. Remember, they share a side and they add up to 180. So here's my 180. Angle 1 and angle 2 share this side here. So therefore, that is a linear pair. So obviously pair is 2 angles. So 2 angles that add up to 180. Sum of 180. Okay? Now it says angle ABC and angle DBC are a linear pair. Now before I even move on, I'm just going to draw a picture of that because that's just how my brain works. Here's my straight line because they're a linear pair. And I know they're going to share a side, so I'm going to go like that. Now I'm going to label some points. So A, B, C. And my other angle is DBC. DBC, perfect. Now as we can tell, they add up to 180 and they share BC. Okay, we're good there. Now they're telling us the measure of angle ABC is 3x plus 19. And the measure of angle DBC is 7x minus 9. What are the measures of angle ABC and DBC? Justify each step. Okay, there's that word, so we know we're writing a proof. So let's start off with what we know. Well, we know that ABC and DBC are a linear pair. That's given to us. So we're going to say angle ABC and angle DBC are a linear pair. How do we know that? Well, they gave it to us, so we just say that is given. It's just a given. That's all we know about it, okay? Now, what do we know about linear pairs? Well, I know that the measure of angle ABC plus the measure of angle DBC equals what? I know it equals 180. That is definition of a linear pair. Scroll down a little bit here. Okay, now what do we know? Do I know what angle ABC and DBC are? Sure I do. So I'm just going to substitute in. So I know ABC is 3x plus 19. 3x plus 19. And I know that DBC is 7x minus 9. And all we did there, guys, was substitute in. So that's substitution. Now I'm going to add my like terms. My x's go together, so 3x plus 7x is 10x. And my numbers go together, so 19 minus 9 gives me 10. That's just simplifying. Now we're just solving for x. So how do we get 10x by itself? I subtract the 10 over. 180 minus 10 is 170. That was subtraction. Property. And my last step is to divide by 10, so we get x equals 17. And that was division. Okay, now remember, we have to answer the question, so we have to plug back in to find these angle measures. But before we do that, let's make sure we have the same amount of work steps and reasons. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we check out there, it lines up nicely. Now we're just going to plug in to find out what each angle is. So angle ABB, or excuse me, ABC, we're going to have, let's see here, 3x plus 19. Plug in what we had for x, so 3 times 17 plus 19 gives me 70. And then I have angle DBC. Not 3, look at the wrong one, sorry guys. 7 times 17 minus 9, that gives me 110. And again, we can check ourselves, right? So we know it's a linear pair, so what do these have to add up to? 180. Do they add up to 180? Yep, so we check out across the board. We're good there. Now an angle bisector is just like a segment bisector, and all it is a ray that cuts our angle into 2 equal angles. So here's my big angle here, and then angle, or this ray right here, LN, is bisecting it. So it's giving me these 2 congruent pieces. So having us do an example, so it says, ray LM bisects angle JLN. So let's just draw a picture because it's just easier to see these things if we draw them out. JLN. It's telling us that LM bisects it, so I have M out here someplace. So here we go. I know if it's being bisected, then that these 2 little angles are congruent. Okay, now go back to the problem. If measure of JLM is equal to 42, so JLM. So if this guy's 42, what is JLN? So JLN is here. So I want to know what the big angle is. Well, if I know that this small guy is 42, I know that this has to be 42. So to get the big angle, we just add them together. 42 plus 42 gives me 84. Name a pair of adjacent angles. So remember, they share a side, so pick any 2 angles that share a side. I'm going to do an angle 2 and angle 3. Name a pair of vertical angles. Remember, you're looking for straight lines here, so I'm going to do angle 6 and angle 2. Name a pair of complementary angles. Remember, those add up to 90. So look, we have a little hint here. Here's a little box for 90 degrees, and that is formed by angle 5 and angle 4. Name a pair of supplementary angles. Again, those add up to 180. So find 2 angles that add up to 180. Well, here's my straight line. My only option on this one would be angle 6 and angle 1. And similarly, a linear pair, remember, is 2 angles that form a line. So my only option there again would be angle 6 and angle 1. Given the measure of angle 2 equals 7x plus 4, and the measure of angle 6 is 5x plus 10, solve for x and justify. So again, we're writing a proof here because it says justify. Now let's label what we know. So I know that the measure of angle 2 is 7x plus 4. And then I also know that the measure of angle 6 is 5x plus 10. All right, so where can we start? Well, looking at our diagram, what do we know about angle 2 and angle 6? We know that those are vertical angles. So why don't we start there? So we're going to say that angle 2 and angle 6 are vertical angles. Are vertical. And that's given to us just by the diagram. And now, since I know angle 2 and angle 6 are vertical angles, I know that the measure of angle 2 is equal to the measure of angle 6, because that's the definition of vertical angles. Remember, they're congruent. Now, do I know what the measure of angle 2 is? Well, sure I do. It's 7x plus 4. And the measure of angle 6 is 5x plus 10. That's just substitution. And now I'm just solving for x. So I want to get my x's to one side and my numbers to the other. I'm first going to move my x's, so how am I going to get rid of this 5x over here? I'm going to subtract 5x. So 7x minus 5x is 2x plus 4. My x's go away on the right side, so that's just subtraction. And then my last step here is to get 2x by itself, so subtract 4, subtract 4. I'm going to get 2x equals 6. Again, that is subtraction property. You guys can write that in. And lastly, I'm going to divide by 2, so x equals 3. And that is the division property. So again, let's make sure we have the same amount of steps and reasons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And all we had to do there was solve for x. We're going to skip the next one, and then we're going to finish up here on this last page. So for exercises 8 through 11, can you make a conclusion from the information in the diagram? So it says angle CEG, oh boy, you gotta mark these out, CEG is congruent to angle FED. Yep, because you guys notice how those are vertical angles? So we're going to say yes, vertical angles. Number 9, DE, where is DE? So from here to here is congruent to EF. Are those congruent? Well, we know that is true because of these little tick marks telling us they are congruent. So we're going to say yes, congruent marks. Now we have angle BCE. BCE is right here. And angle BAD are congruent. Well, I know nothing about this angle here and that angle there. We don't know any properties for that, so we're going to say not enough information. Not enough info. And our last one here, angle ABB. Angle ABB. And angle FBE are vertical angles. And yep, you notice that we have two straight lines making those angles, right? Here's my straight line and here's my straight line. So that guy and that guy are congruent. So we'll say yes, formed by, you guys finish that out on your own since this popped up. Yep, formed by straight lines. Thank you for watching. Again, let me know if you have any questions.